Today we're going to be doing a two-part video, and in this video we're going to learn how to prove that this structure, which is represented by the set G equals -1 to 1, and its binary operation x star y, which equals x plus y over 1 plus xy, is an abelian group. To show that this structure, G star, is an abelian group, we first need to show that this star is a binary operation, meaning that if I take any two members of the set G, then x star y is also in G. And in the next video, we'll show that this structure needs to satisfy the following properties in order for it to be an abelian group. It needs to be, first, commutative, then associative, then it needs to have identities, and then it needs to have inverses. So in part one, we're going to show that the star operation is a binary operation for -1 to 1, which is our G. So how we do this is we say let x and y be members of G, which is equal to -1 to 1. And what does this mean? Then the following is true. If x is a member of G, then we have this inequality. And if y is a member of G, then we have this inequality. Why is this the case? Because remember that x and y belong to this interval, -1 to 1. So x has to be between these two values. So what can we do with this? This means that the absolute value of x is less than 1, and the absolute value of y is also less than 1. Then, by definition of the absolute value, we know that the square root of x squared is less than 1, and the square root of y squared is less than 1. This means x squared has to be less than 1, and y squared has to be less than 1. Now notice this. We can move the 1 over. We have x squared minus 1. This means that this is less than 0. And y squared minus 1 is less than 0. So these are two negative numbers. These are both negative. Meaning, so we have x squared minus 1 times y squared minus 1. This has to be positive because negative number times a negative number gives me a positive number. So with this, I have x squared minus 1, y squared minus 1 is bigger than 0. So x squared y squared minus x squared minus y squared plus 1 is bigger than 0. Now, I need to move these guys over. I have x squared minus or plus 1 is greater than x squared plus y squared. Now, what I need to do is recall the form of the binary operation. So recall So notice that I have x plus y on this side and then xy plus 1 on this side. But the problem is that these are squared. So what I need to do is complete the square in order to isolate these terms right here. So by completing the square, I obtain And if you're wondering how to complete the square, you can do the scratch work on the side. So I'll separate this and put the scratch work on the side. So in order to complete the square, what you need to do is remember this expansion right here. So what I need to do is determine what my a squared is. My a squared is equal to x squared y squared. So then my a is xy. Okay. So then also my b squared is equal to 1. So then my b is equal to 1. So then my 2ab is equal to 2 times xy times 1, which is 2xy. So in order to complete the square, because I want to get from this expression right here to this expression, I need to add in this term. And then if you do the same thing, you'll find that this is also going to give me this on this side too. So now, by completing the square, I know that this is equal to xy plus 1 squared. This is greater than x plus y squared. Now, dividing both sides by this term, I see that 1 is greater than x plus y over xy plus 1 squared. Now, we can reverse what we did in the previous section. We know that 1 is greater than the square root of x squared or x plus y over xy plus 1 squared. Now, using the definition of the absolute value again, we see that this is 1 is greater than the absolute value of x plus y over xy plus 1. Then finally, we can see 1 is greater than x plus y over 1 plus xy. So we have this term is going to be negative 1 less than x plus y over 1 plus xy is less than 1. So what does this mean? This means for any x and y in negative 1 to 1, which is equal to g, then x plus y over 1 plus xy is equal to our binary operation, x star y, which, as we just proved, is a member of -1 to 1, because if you notice that this is -1 less than our binary operation, which is less than 1, but this is equal to g. So what does this mean? This means that this right here is a binary operation for g. And in part 2, we'll prove that g is an abelian group.